Here we've got a physics example. In this problem, they're giving us an equation that tells us a particle moves along the line so that at time t, its position is given by this position equation right here. And then they start asking us questions involving the velocity and the acceleration. So what we know is we've got to remember our physics relationship table. So it's one of those things you just got to have down when you go to take a test on this stuff. So our physics relationships say that if we start with the original function as the position function, then the first derivative of position is velocity. And then the second derivative of position, which would be the first derivative of velocity, is equal to acceleration. So that's the relationship we need to know. We'll need to know it taking derivatives right now, and then we'll need to know it working on antiderivatives later on in this class. So this problem is specifically asking us, it wants to know what is the velocity, so that's this equation, when the acceleration is 0. So the first thing we'll probably have to do on a problem like this is go ahead and find that velocity equation and find that acceleration equation. We're going to need them both. So starting with our original position function, so s of t equals 1/2 t to the third minus 7/2 t squared plus 5t plus 20. First thing we need to do is find the velocity equation, is find that first derivative. So in this situation, we'll get out s prime of t, our velocity equation, following our power rule. This is nothing but a bunch of stuff being added and subtracted, so our power rule for finding derivatives is all we need. We bring the power down, we get 3 times 1/2 gets us 3/2 t, subtract 1 from the power gets you t squared. Doing it again here, bring the power down, 2 times negative 7/2, the 2's cancel, we get negative 7t, subtract 1 from the power gets us t to the first. We got that unwritten 1 on that t. We bring that 1 down, multiply it by 5, and that gets us 5. Subtracting 1 from the power gets us t to the 0. Anything to the 0 power is 1, so 5 times 1. And then the derivative of 20 is a constant. That's always going to be 0. So we now have our velocity equation. To find our acceleration equation, we're just going to do the same thing. We're going to take our derivative of our derivative. So we're getting our second derivative right now, our acceleration equation. Power rule, bring the 2 down, the 2's cancel, we get 3t, subtract 1 from the power gets us t to the first. We got an unwritten 1 right there. 1 times negative 7 gets us negative 7. Minus 1 gets us t to the 0. And again, anything to the 0 power is 1, so negative 7 times 1. And then the derivative of 5 is a constant, it goes away. So we now have our acceleration equation. Looking back at what they're asking us for, they want to know the velocity. So they're looking for this bit of information when the acceleration is 0. So when this equation is equal to 0. So that tells us we have to find that time. So you'll take your acceleration equation, 3t minus 7, and you want to know when does that equal 0. So we set that equation equal to 0. And then we just solve this real quick, do some algebra to find out what our specific t value is. So add 7, we get 3t equals 7, and then go ahead and divide by 3, and we get t equals 7 over 3. So that is the time that the acceleration was equal to 0. And so now that we know that, we're just going to take that and pop that back into the velocity equation, because that's what they really wanted to know, is what is the velocity? So v of t is equal to 3/2 t squared minus 7t. What is that velocity at this specific value? So we want to know v of 7 over 3. That's when the acceleration equals 0. So 3 over 2 times 7 over 3 squared minus 7 times 7 over 3 plus 5, right? So stick that into your calculator, pump that value out, and so out of there we are going to get, plugging in 7/3, we get negative 19 over 6. So that is the velocity at the moment that our acceleration is equal to 0. So now what that's telling us, just so you know, remember with these physics situations, positives and negatives, the negative is just telling us a direction. So we're moving backwards at 19/6, and they usually want some units on this, but this problem didn't give us any. Always keep track of your units. It's probably something like meters per second or feet per second. That answers part I right now. To answer the second part of this problem, we want to know, is this thing speeding up or slowing down? Things are going to be speeding up if the first derivative, your velocity equation, is equal to your second derivative as far as positive or negative. So if the velocity is positive and the acceleration is positive, that tells us that it's speeding up. If the velocity is negative and the acceleration is negative at that point, that tells us again that it's speeding up. Because remember, the positives and negatives are just telling us direction. So speeding up going backwards looks like negative, negative. Speeding up going forwards looks like positive, positive. And then the other way this could come is saying what's happening is you're slowing down. Well, that means your velocity and acceleration aren't equal to each other as far as positive or negative. So if your velocity is positive and your acceleration is negative, that means you're slowing down. And if your velocity is negative and your acceleration is positive, that means you're slowing down. Your pieces are going in the opposite direction. This problem specifically wanted to know what's happening at the time t equals 4. So we really, to see if it's speeding up or slowing down, we just plug 4 into the velocity equation, and then we plug 4 into our acceleration equation. And we compare the sign. We really don't care about the number, we just care about the sign. So plugging into our velocity equation, that was our first derivative here, we get 3/2 times 4 squared minus 7 times 4 plus 5. And so out of there, that is going to give us a positive 1. Again, really just worrying about the signs. That's a positive 1. And then plugging 4 into our acceleration equation, our second derivative here, we would get 3 times 4 minus 7. That gets us 12 minus 7. That gets us 5. Again, though, we really just care about the signs. So that is positive. So because the signs here are the same, they're both positive, that tells us that we are speeding up. Specifically, we're speeding up going forward. So whenever you need to know if you're speeding up or slowing down, compare your velocity and acceleration. If their values are both positive or both negative, you're speeding up. If the values are different, so positive, negative, then you're slowing down. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.